Hi folks, welcome back. We're just going to continue on with patterns and sequences today, and I'd just like you to add another example to your notes after the example that you took down yesterday. And this example is just going to take the idea of patterns a little bit further. It won't be an awful lot of extra work. So after we've finished this, maybe you could put this into your notes copy. So the example is, it's dealing with a different type of pattern, a pattern which doesn't have numbers in it. It's going to be a picture sequence or a pattern of images, if you like. So the example says, given the following pattern or picture sequence, and this is the picture sequence. Excuse my drawing, it came out badly enough when I was drawing it. These are just 3 dots, 4 dots, 5 dots, 6 dots, and don't worry about this little mess in here, that's just one of the dots. Okay, so then from that they're asking you to draw the next stage of the pattern. Okay, draw the next stage of the pattern is the first one. And I think from what I've said already, you could nearly guess 3 dots, 4 dots, 5 dots, 6 dots. It's just going to be 7 dots, isn't it? So we'll put in 1, 2, 3, 4, 5, 6, and 7 dots. Okay, that's the first part, so fairly straightforward. The next part then is give a rule for the number of dots at any stage of the pattern. Now, here's the thing. With these picture sequences, and even sometimes when you're doing a question like the first part here, draw the next stage of the pattern, sometimes it's handy to have converted the pictures into number form in any way you can. And usually, because the pictures are a sequence of items which are, either increasing or decreasing, it's just to convert the pictures into a number sequence, you just count the number of items. So for instance, in this one, there's 3 dots, 4, 5, 6, 7 dots. So to convert it into a number sequence, you can just say 3, 4, 5, 6, 7. Okay, and then it keeps going on afterwards. Okay, so that being the case, when we get on to the next part, it says, give a rule for the number of dots at any stage of the pattern. Okay, now, like yesterday, we had the terms nth term or general term or term n. Well, they might also say something like give a rule or give a formula that describes it. But what they're talking about again is term n or the nth term or the general term. So in order to find any of those, remember yesterday we used our formula which said that term n is equal to a plus n minus 1 times d. Okay, and we sub in the values for a and d into this formula to get our term n or to get our rule. Okay, so a, we already said a was equal to the number at the start, so the very first one is 3. And d is equal to the common difference, because we can only use this with a linear sequence, and this is a linear sequence if we went to check it out. Let's just check it out. This is how we check it out. Goes up by 1, goes up by 1, goes up by 1, goes up by 1. So there is a common difference. The first difference is constant. So d is equal to 1. So when we want to find our Tn, or our rule, it's going to be a, which is 3, plus, we don't sub in anything for n when we're looking for the rule, n minus 1 times d, which is 1. Okay, so then I multiply out the brackets. 3 plus, well, n minus 1 times 1 is just n minus 1. And then I can tidy it up a little bit more. I'll go over here. Term n is equal to 3 take 1 is 2. So it's n plus 2 or 2 plus n. Really, the order that you write that in is irrelevant. N plus 2 or 2 plus n would be equally correct, equally valid. Okay, so that's your rule there. The next thing then is, if there were 25 dots at some stage of the pattern, what is the stage number? Now, a few things to note about that, because this is new territory from yesterday. When they talk about what is the stage number, sometimes instead of calling these terms like term 1, term 2, term 3, term 4, term 5, they'll call it stage 1, stage 2, stage 3, stage 4. So when they say a stage in the pattern, they're talking about a term or a position still, like the 5th stage is the 5th term is the fifth position, isn't it? So it's position we're talking about. So that's the first thing, that sometimes they'll use stage instead of term. The second thing is, if there are 25 dots at some stage of the pattern, what is the stage number? Now, yesterday we were used to starting with the stage number, like saying if you had the formula here, here, and you wanted to find out what was the for instance, the 33rd term, you'd sub in 33 here, and the 33rd term would be, or term 33 would be 33 plus 2, it would be 35. Well, in this case, we're doing it backwards. They're telling us what the number is at the particular stage. In this case, the number of dots, 25 dots. So 25 is some number further on in this pattern. So they're giving us the answer, if you like. They're giving us the term, and they want to know what position that term is in. Okay, at some stage of the pattern, what is the stage number, or what term is it? Okay, what position is it? So in this case, and in other questions similar to this, what we do is a little different. We start with the formula. Okay, and if we know that n plus 2 must turn out to be 25, well then we just let n plus 2 equal to 25, and we work out what is the n that will make n plus 2 equal to 25. And that's just simple algebra after that, isn't it? N is equal to, bring the 2 across to the other side, it becomes a minus 2. N is equal to 23. So if you like, in the words we used yesterday, term 23 will have 25 dots, or it's the stage 23 will have 25 dots in it. So your answer, if you like, so since they ask, and what is the stage number, we'll call it, stage 23. Okay, so that's it for that. I'll give you some questions to do in a moment. One other thing to say, they won't always lead you by the nose in these questions. Sometimes they'll give you a pattern, a number pattern like this, or a number sequence, and they'll say, find the, we'll say 1064th term, okay? Now, that means that you're going to have to realize that what they haven't asked you is to find the nth term and then use the nth term to find whichever term it is that they've asked you for. But you must realize that, okay, though they haven't asked me to do that step, I must do that step first, and then I'll be able to answer the question that they've asked me. So just watch out for that. Anytime they ask you for terms with very large numbers that are, we'll say, very far on in the sequence of numbers, you will probably have to get the general term first, whether they've asked you to find it or not.